Hello students, in this video we'll see how to compute the cross product and triple scalar product using the Kronecker symbol and the permutation symbol. If we have a vector v, which we can now write as the sum, I goes from 1 up to 3 of vi delta I hat, and w, which is the sum j, goes from 1 to 3 of wj delta j hat. So we have a delta j hat here. Delta j hat. Now we know that if I look at delta I cross delta j, we can show that this is the sum, k goes from 1 up to 3 of epsilon ijk delta k hat. So using this fact, what we can do now is we can cross these vectors v and w. So if we do that, what we get, this will say that v cross w is going to be the sum. I goes from 1 to 3 of vi delta I hat cross the sum. J goes from 1 to 3 of wj delta j hat. And now we can see that this is going to be equal to, I'm going to have a delta I cross delta j. That's going to introduce a new sum over here. So I'm going to have three sums. I'm going to have I goes from 1 up to 3. J goes from 1 to 3, and K goes from 1 to 3 of epsilon ijk. I'll have a vi, I'll have a wj, and I'll have a delta k hat. Now this is a long way of expressing the what? This is a long way of expressing with these three sums the cross product, but we'll see this gives us flexibility to use different identities with these permutation symbols to make calculations. So we have this relationship that v cross w is this expression over here. Now what we like to do is we like to find a formula for the triple scalar product. So recall that if I have a vector u, comma, v, comma, w, this is the triple scalar product, is u dot v cross w, the triple scalar product. So if we write this out, what will this be? Well, I'm going to have this u is going to be the sum. I goes from 1 up to 3 of ui delta I hat. And we're going to dot this with, I'm going to need three new indices. I'm going to dot this with the sum. J goes from 1 to 3. K goes from 1 to 3. And I'll use L goes from 1 to 3. And then what we have, we'll have epsilon j k l. I'll have a vj, I'll have a wk, and I'll have a delta L hat. Now we're going to have a total of 4 sums when we do this. So this is going to be the sum I goes from 1 to 3, the sum j goes from 1 to 3, the sum k goes from 1 to 3, the sum L goes from 1 to 3 of what? Of epsilon j k l. Then we're going to have a ui, a vj, and then a wk. And then we're going to have delta I dot delta L. Delta I dot delta L is the Kronecker symbol, delta IL. Now whenever you have a Kronecker symbol that says that you replace all the i's with l's or all the l's with i's, you can contract and get rid of one of the sums. I will choose to eliminate the we can choose to eliminate the I sum over here, for example. And what we'll get if we eliminate the I sum is we'll have just a sum over L. So the i's will turn into l's. This is equal to the sum j goes from 1 to 3. The sum k goes from 1 to 3. The sum L goes from 1 to 3. Then I'll have an epsilon j k l. My i's will turn into l's. I'll have a ul, a v j, and a wk, and we can actually realize this formula over here. This formula just gives me what the determinant is by definition. So this by definition over here is going to be equal to the determinant of the matrix I get when I put a what? When I put the u over here, u, v, w. So this would be exactly just be the determinant of those three values. Thank you very much.